Welcome back, physicists. Today we're going to take a look at acceleration, thinking about how to define it, how to calculate it, what its direction means, and making sure we know what its units are. So we've already started off with our first kinematic variable of position, and we asked the question, what if that position is changing? And we wanted to characterize that change by calculating the velocity. We do that by finding the change in position and dividing it by the change in time. Now, so far we've looked at situations where the velocity remains a constant. But of course, that's not necessarily the only thing that could happen. And we might ask the same question of what about if that velocity is changing, right? If we follow the same train of thought, we're going to find the change in the velocity divided by the time that it takes, and we'll call that thing the acceleration, right? And that's big picture what we're trying to accomplish. So let's start off with a number line. And let's put some positions. So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And I will put a position at 0, 1, 4, and 9. So this is 0, 1, 2, 3 for time. Okay. Right. So next I can go in and I can draw those displacement arrows. Okay. Okay. And let's make a little chart to help us stay organized. So I've got my time value. Okay. So 0, 1, 2, and 3. I have my position value, 0, 1, 4, and 9. And next I want to figure out what is that change in position between successive points. So between 0 and 1, we see that change is plus 1 meters. Between 1 and 4, that change is plus 3 meters. And between 4 and 9, that change is plus 5 meters. And what we notice is every second that goes by, we are not changing our position by the same amount. We're changing by more and more each second that goes by. So let's turn this change in position into a velocity by dividing by the time. And I made it easier on us, making the time in between equal to 1 second. So the velocity is plus 1 meters per second, plus 3 meters per second, and plus 5 meters per second. Let me add, let's now focus on perhaps what's happening between the first interval and the second interval. So we start, our initial velocity is 1 meter per second to the right, and our final velocity is 3 meters per second to the right. And so the question we're asking ourselves is, what do we have to add? What is the change in the velocity that we have to add or subtract so that we end up with our final? And the way we want to think of the adding or subtracting is like the direction, right? So if I want to go from something that is 1 meter per second to the right to something that is 3 meters per second to the right, I have to add to that plus 2 meters per second. Okay. And if I follow that trend down, I see, well, in the next interval, I go from 3 meters per second to 5 meters per second to the right. And that would also correspond to plus 2 meters per second. So this change in velocity is plus 2 meters per second. So if I take this and bring it to my equation, and I want to find the time rate of change, I then have to divide by the time that it took. So the change in velocity divided by the time over which that change took place, plus 2 meters per second divided by 1 second. And this is where we bring back that practice we had about like dividing by that unit. I end it with 2 meters per second squared. Okay. Now, the other thing we want to think about is, well, how does the direction play a role in whether the velocity is increasing or decreasing? So here, what we see is that the velocity points to the right, and the change in velocity also points to the right. And so our velocity, or actually a better way to think of it is our speed is increasing. Whereas if we had our velocity to the right, but our change in velocity pointing to the left, this would result in like a subtraction and our speed would decrease. So we can then take these arrows and flip them. So what we're looking for is if the change in velocity, which is related to the acceleration, if that is parallel to the velocity, the speed increases. But if the acceleration is in the opposite direction of v, then the speed decreases. All right, thanks for watching.